So problem one was pretty straightforward. Things moved from high to low. The material was able to pass through the membrane. Problems 2 through 7, there was some confusion in the way we were discussing it. The morning made things a little bit hectic. So I thought, let's make sure you understand what we're talking about here. So to be clear, when you have a cell where you have something that diffuses 10% glucose, how do I know glucose diffuses through this membrane? Because the problem told me it did. They have to tell you what does or does not pass through. And 60% starch, okay? So then outside it's 60% glucose and it's 10% starch. Now let's be clear, starch does not pass through the membrane. All right, so if we're going to go ahead and say does not pass, and in fact it's going to be starch that determines if water diffuses or not, because glucose is going to diffuse. There's going to be movement of glucose from high to low, and that's going to come to some kind of equilibrium. So because this equilibrates, the only thing that's going to be a difference in concentration in the cell is going to be this 60% and this 60% and this 10% that's starch. Those are going to be the only two that are really going to be that are going to determine the percent water, the difference in the percent water, if you will. Because these two end up being equal in the end, the only difference between the two sides of the membrane is going to be the starch. So that's the only one we're going to worry about. So there's two ways to work this out, as we've said in the past. You can worry about how much water there is, and so if these two equilibrate, the percentage is going to be somewhere between 10 and 60%. Let's just say, for argument's sake, that this turns out to be, let's say that this turns out to be, 30. This moves to 35%, and here's 35% out here, just for argument's sake. So that's equal. So the percent water on the inside, the total percent water on the inside is going to be 35 and 60, which is 95% starch, and it's going to be what percent water? Hopefully you say 5% water, because that's what we have. So that's just, again, that's an argument of what happens to this. We know they're going to be equal, but we know this is going to go up, and the percent glucose on the outside is going to go down. So if they end up being equal, it's going to be about 35% each way. Now with starch, it's 10% outside, and 35, so 35 for starch percent, of course, plus 10% starch is going to be 45% total, right? And this is solute. And I made a mistake here because this isn't starch, this is solute. And so here we have 45% solute, so that means you have what percent water? That's 55% water, right? To equal a total of 100. So your water's fit is 55% outside. Your water's 5% inside. So water's going to move into the cell. So there is going to be osmosis. I believe it in the previous examples, discussions, we had said water wasn't going to move. In some cases, there's all kinds of confusion on what was going on, but this is exactly what's going to happen. Water's actually going to move into the cell. So osmosis is occurring, even though if you did the math before the glucose settled out, if you did the math before this glucose settled out, you would have found the percent water to be the same on both sides. But because starch doesn't move and glucose will come to equilibrium, you're going to have to deal with the fact that starch is going to determine if water moves or not, and starch is higher concentration inside than outside, so water is moving into the cell. Now there's an easier way of doing this, and I'm going to show you right now. And so hear this very clearly. If you have 10% glucose and 60% starch, and outside they tell you it's 60% glucose, and outside is 10% starch. If they're telling you that, then just try to realize that these are going to equilibrate, so you don't have to worry about them, and just focus on the starch versus the percent starch on both sides. And since this is a higher solute, right? So think of it more, instead of percentages necessarily, think of it more as either high or low. This has a high solute concentration, right? So that means it has a low water concentration. High relative to what? High relative to 10% outside. And so here, this on the outside, this is of course inside. Here on the outside of the cell, you have a 10% starch solution, which tells you it's much lower, so you have a low solute concentration. Therefore, you have a what? A high water concentration. So when you look at the comparison, when you compare these, and you're asking yourself, where does water move? You have to ask yourself, in what direction is water moving? It's going to move from high to low, so from outside to inside. So water moves from out to in. Water moves from out to in. And of course the cell is going to swell. And is this solution isotonic, hypertonic, or hypotonic? Initially, the solution is indeed isotonic, right? Because it's 70% solute inside and 70% solute outside. However, after the glucose is all settled out, after the glucose has gone through diffusion, then you have the conditions are slightly different. So in both cases, if we look at it, when we have this cell, and it's now 35% on both sides. And again, we're making this number up, but let's say there's going to find some equilibrium, and just a midpoint between 60 and 10, 35. So 35% on each side, and you have 60% water, 60% starch on this side, and only 10% starch on this side. Now you have a total of 95% solute inside, and you have a total of 45% solute outside. So this turns out to be a hypotonic solution after you have the diffusion of glucose. So you have the solute, because the solute concentration outside is lower than the concentration of solute inside. So that's the answer to question number 2. All the parts 1 through 5. So let's take the next question, which is question 3. It gives you 3 ions. And it gives you 10% potassium, 10% sodium, 10% starch. Your starch doesn't move. On the outside, you have 100% water. To be honest, at this point, nothing else matters. Once they tell you it's 100% water and you have any solute on the inside, even though these two move, right? Both potassium and sodium, according to the problem, do diffuse. The membrane is permeable. These two do diffuse again, so the membrane is permeable to these 2 ions. So they're going to diffuse, and but you have 100% water. So if we follow the same logic that we did in the other problem, then over time, right? If we had time, if we considered the change that would happen, is you would have the potassium and the sodium balancing each other out. So let's just say 5% inside and 5% outside. Let's just say that happens. That's sodium and potassium. Sodium and potassium. All right, so assuming they balance each other out, you still have 10% starch out here. Again, this is, for argument's sake, let's say this is what happens. So these two, so what ends up happening is that the ions or the solutes that can pass through the membrane, they don't impact osmosis, right? So if they could pass through completely, if all of 3 of these solutes could pass through the membrane, then there would be no osmosis going on. But because we have this one that doesn't pass through, that 10% starch is still present. So outside you had 100% water, but now you don't. Now it's 90% water. And 10% sodium and potassium. But inside you still have 10% starch and you have 90% water. So well, that's wrong. That's a mistake. Thanks. All right, so this was a mistake here. This is not 90% water because I forgot about the 10% potassium and sodium. Let me just do it this way. If we look at 10% starch, but then these two add up to 10%. So it's 20% solute inside. And of course that means it's 80% water. So still we get this movement of from 90 to 80. Still we get water increasing the volume of the cell. So the cell swells. All right. And the reason it swells is this idea that you have this inside 20% solute, 80% water, and outside you have 90% water and 10% solute. Anyways, that's the idea. Hopefully you get that. Again, we can do this really much easier rather than trying to worry about all that. And if we just think about what we might have been able to do is to take a look at this and say it's 10% potassium, it's 10% sodium, and it's 10% starch. It's 100% water. If we say, look, these two here, we can just ignore them. And the reason we could ignore them is that is that they're going to be able to diffuse. They're going to diffuse and they're going to equilibrate out inside and out. This won't be 100 anymore. It'll be something smaller than 100, but it's still, they're not going to be anywhere near the concentration, because you still have this 10% starch no matter what. No matter what happens with this concentration, these are going to equilibrate. They're going to reach equilibrium, but the starch will never will not reach equilibrium. And so if you're going to ask what's going to happen, you can just, for argument's sake, ignore the solutes that can pass through and just say, well, the inside the cell, I have high solute. Notice I didn't say how high, but it's high, and therefore it's low water. Outside the cell, it's high water concentration, right? But low solute concentration. Since that's true, it's going to go from high to low. And that's it. All right, let's go to the next one. So I'm going to send the next 5 questions in the next post. So I'm trying to keep this series of answers in short, reasonable sections.